Hello everybody. Last session I talked about the percent composition by mass and how to calculate it, and today I want to solve you the previous practice from last session, and then we will go forward with the some practices regarding the new lesson. Regarding the sulfuric acid and finding the percent composition by mass of each of its elements, first regarding the hydrogen present in this compound, the percent composition by mass of hydrogen in sulfuric acid is the number of the hydrogen present multiplied by its atomic mass in gram divided by the molecular mass of the compound, 1 mole, 76 gram of the sulfuric acid, multiplied by 100 because it's percent, and it gives us 2.056%. For the sulfur, the percent composition is as follows, the same like hydrogen. Its atomic mass 3206 gram of sulfur. When I say atomic mass of 1 mole, don't consider of the mass of only one atom. We are talking about a mole of the sulfur divided by the molecular mass 98.076 multiply by 100, which gives 32.691%. And even for the oxygen, I will write here, the oxygen is as follows. We have 4 oxygen in this compound, so we need to consider it by its atomic mass divided by the same 98.076 gram multiplied by 100, which gives us 65.253%. That was the result of this practice. Well, today I want to solve this. I want to answer to this question: why is percent composition by mass of a compound important? Okay, from this calculation we can reach something valuable that I give you. Given the percent composition by mass of a compound, we can determine the empirical formula of the compound. If you want to know about the empirical formula, you can watch my YouTube video that's with this title, Molecular Formula versus Empirical Formula, and then you will find what are the differences between these two formulas. Then for today, if we want to give an answer to this question, when we have the percent composition by mass of a compound, we can find the empirical formula by following this procedure. First, we need to convert the quantities in grams to moles, which I will show you, however, how to solve different problems already. We already solved different problems regarding the conversion of gram to moles and vice versa. However, in this problem, even we will solve it. For example, consider the following problem. Ascorbic acid or vitamin C cures scurvy. It is composed of, so if I want to write vitamin C composed of 40.92% of carbon, 4.58% of hydrogen, and 54.50% of oxygen by mass. So we have these data. Determine its empirical formula. First, if we have 100 gram of vitamin C, then each percentage can be converted directly to grams. So based on 100 gram of this compound vitamin C, so we have 40.92 grams of carbon, and in the following 4.58 grams of hydrogen and 54.50 grams of oxygen. So now first we converted each percentage to grams. Then we need to convert the grams of each element to moles. So let's consider N represent the number of moles of each element. So directly I will write here, if we want to convert each gram to moles, we can write like that. I will draw a line here. So NC represent the moles of carbon. So we have 40.92 grams of carbon. As I mentioned you, if we consider 100 gram of the compound, and we know that from the periodic table and from previous lesson, 1 mole of carbon is 12.01 gram carbon. And simply now we can find the moles. 3.407 mole of carbon. For the following elements, the number of mole for hydrogen, as we have 4.58 gram of hydrogen, multiply by 1 mole hydrogen has 1.008 grams of hydrogen, and we can reach this number 4.54 mole. And finally for oxygen, 54.50 gram of oxygen. In 1 mole oxygen is almost 60. Previous time I considered 50.99, but even it's 60, so gram of oxygen. And for oxygen we have it like 3.406 mole oxygen. Consider that this section I will solve some problems that are a bit long, so let's be patient, that I'm sure all of you are, and then we can solve it step by step. Now we converted all grams to moles, and then I will write here we arrive at the formula. If I want to write the formula by the moles that I have got, I can write here like that: C 3.407, H 4.54, and O 3.406, which gives the identity and the mole ratios of atoms present. However, chemical formulas are written with whole numbers. Now, try to convert the whole numbers by dividing all the subscripts by the smallest subscript. The smallest one is that. So I will try to divide all of them by this small subscript. 4.6. And the last one, 3.4.7. So I can reach this point. I'm sorry, I should convert it to 6 but not 7. Everything is correct, yes. So this division it almost give me approximately this division equals to 1. For the hydrogen, it equals to 1.33, and for oxygen, it's exactly equals to 1. So now my formula is like that. If I want to write it, C1H 1.33 O1. This okay, and so however, I wrote the subscript 1, but since it's 1 we can ignore it, but however, for more clarity I wrote it. This is as the formula for ascorbic acid. Next we need to convert 1.33, the subscript for hydrogen, into an integer. This can be done by a trial and error procedure. How we can do that? If we multiply 1.33 by 1, we can get the same. If we multiply it by 2, we can get 2.66, and if we multiply it by 3, we can get 3.99, which is equal to 4. Because the multiplication of this number by 3 gives us an integer 4, we multiply all the subscripts by 3, and then, okay, let's try to multiply all of them by 3. If I multiply all these integers by 3, I can get this formula. C3H4O3. It can be considered as the empirical formula for ascorbic acid. Okay. Now, we want to experimentally determine the empirical formulas. You know that when we have a compound, if we want to find the percent composition by mass of each element, we need an apparatus in order to actually make our compound to its ions, and then determine the electron to mass ratio of each ions, and that's and then we can get the percent composition. So the fact that we can determine the empirical formula of a compound if we know the percent composition enables us to identify compounds experimentally. So the procedure is as follows. Chemical analysis tells the number of grams of each element percent in a given amount of a compound that I told you. Mass spectrometer is a technique which can determine the mass of each element in a given compound. If you are interested to know how it works, you can write me in comments, so in a new session, in another session, I can describe for you this apparatus. Conversion of quantities in grams to moles, the same that we did in last example, and then using the method given in previous example. What was that? Okay, so then we need to divide the subscripts by the smallest one and then find the integer, because all the subscripts are a whole number. Let's solve this problem. After burning a specific amount of ethanol, these amounts of carbon dioxide and water will be produced. What is the empirical formula of ethanol? Because neither carbon nor hydrogen was in the inlet gas, they weren't in the inlet gas, we can conclude that both carbon and hydrogen were present in ethanol, and that oxygen may also be present. molecular oxygen was added in the combustion process, but some of the oxygen may also have come from the original ethanol sample. The masses of carbon dioxide and water produced can be determined by measuring the increase in mass of the carbon dioxide and water absorbers respectively. Suppose that in one experiment the combustion of 11.5 gram of ethanol. So I will write it in a white page clearly. So we have 11.5 gram of the ethanol that was injected to the apparatus. This amount produced 22 grams of carbon dioxide and 30.5 grams of water. We can calculate the mass of carbon and hydrogen in the original 11.5 grams of the sample as follows. If we want to find the mass of carbon, we can do the following. So I will write here. For mass of carbon, first we have the mass of carbon dioxide, produced carbon dioxide, multiplied by 1 mole carbon dioxide. Now you know how to calculate it. It has the mass of 44.01 gram carbon dioxide, multiply by 1 mole carbon dioxide, we have 1 mole carbon, and we know that 1 mole carbon has 12.01 gram of carbon. So we will reach 6.00 gram of carbon. Now we found it. So the mass of hydrogen is from the water that we have, 30.5 gram of water, multiplied by 1 mole water. How much water in gram? 80.02 grams of water, multiply by, in 1 mole water, how much mole of hydrogen? 2 moles. Great. 2 moles hydrogen, multiply by 1 mole hydrogen, we have 1.008 gram of hydrogen. As like everything, so I didn't show here, all the similar units go with each other, so easily we can eliminate them, and now the only unit that we want is remained. The final result is 1.51 gram of hydrogen. Okay, thus 11.5 gram of ethanol contains 6 grams carbon and 1.51 grams of hydrogen. The remainder must be oxygen, whose mass is, if we want to find the mass of oxygen here, we can consider this. So, mass of oxygen, if I want to write you totally, mass of oxygen equals to mass of the sample, mass of the ethanol minus mass of carbon that we obtained plus mass of hydrogen. So if you sum these two mass and eliminate from the total mass that you already have, you can find the mass of the remaining element, which is, okay, I will write it here. 11.5 minus 6 plus 1.51, which would be 4 grams of the oxygen. Now we have the grams of the elements, and then the next step is to convert them to the mole. Okay, so mole of carbon equals to its gram that we got already, 6 grams of carbon, multiply by, 1 mole carbon is 12.1 gram, and the mole of carbon is 0.5. Mole of hydrogen, the same. Mole of hydrogen is 1.51 gram of the hydrogen, multiply by 1 mole hydrogen has a mass of 1.008 gram, and then we have 1.5. And for the oxygen, the mole of oxygen equals to 4.0 oxygen multiplied by 1 mole oxygen is 60 gram oxygen, and then we have 0.25. Okay, the formula of ethanol should be that. So I will draw a line again here. It should be like that. C 0.5, H 1.5, and O 0.25. The next step is as the same as previous practice. We need to divide all these subscripts by the smallest one. So we will divide all of them by 0.25. 0.25, divide all of them, and then the results of the final division would be like that. I will write here. C2H6O. That is the empirical formula of ethanol that we got from its percent composition by mass that we already got experimentally by the same apparatus that I told you. Now we can better understand the word empirical, which literally means based only on observation and measurement. The empirical formula of ethanol is determined from analysis of the compound in terms of its component elements. Okay, guys, for the next lesson, based on this information that you have, we will find the molecular formula of a compound, and in the following, I will give you a new lesson regarding the balancing of equation, which is important, and I will describe you in an easy and simple way. So follow me for the next and new lessons. See you later.